Hello, everyone. Thanks a lot for joining for this session. As Patricia mentioned, I would like to give you not just a regular webinar, but I would like to provide some exercises, some hands-on workshops. So yeah, let me start with screen sharing. Yep. So I think you should be able to see my screen. Okay, so today's session is entitled Getting Started with Traefik on Kubernetes. It's, as I mentioned, the workshop, so it will be just split into two parts. So it will be a few slides in regards what is the Traefik, what is the connection with Traefik and Kubernetes, and what is the Ingress, and all those actually basics that are required to you to start working with Traefik on Kubernetes. So who am I? My name is Jakub, and I work for Traefik Labs. My role is product adoption specialist. So I'm responsible for working with community, with open source community. So with those who just joined to our session, I'm helping with issue triage every day on our open source project Traefik. And I'm also trying to support our customers. And yeah, personally, I love all what is related in DevOps because I'm a technical person. I have a technical background. So, and I like very much Kubernetes because for me, I think it's the next generation of Linux distribution, but in running on another abstraction layer. So I like very much Kubernetes, everything what is around that ecosystem. Personally, I'm a father of, I have a son, and I like lots of sports activities, especially mountain biking, snowboarding, boxing, and lots of this stuff. You can find me on Twitter. There is a link to there's my nickname on Twitter, so you can find me there and ask any questions related to the presentation, to the products, the Traefik, and everything what is related to, yeah. Okay, let's move forward. So what is the agenda? As I mentioned, we will split that session into two parts. So it will be a few slides that are a little bit of theory, because I would like to be on the same page with you just to explain what is the Traefik, what is the high-level architecture of Traefik, what are the configuration components, what are the crucial parts in Traefik that you should focus on, so static versus dynamic, providers available, entry points, all those stuff. So I will mention a little bit later about it. Then we'll focus what is the Ingress in Kubernetes, how we implemented Kubernetes Ingress, and why we implemented Kubernetes IngressRoute. That is a CRD, a little maybe more complex, but still I will try to explain everything. Yeah, then we'll switch to the hands-on workshop. So I will start from zero to hero, because I will have just an empty Kubernetes cluster that is just deployed. There is nothing installed, and I will be going through each lessons together with you, so you can follow me, and I strongly encourage you to do that. And we will explore a little bit dashboard. We'll deploy sample application. We'll try to expose that application to our users. We use a TLS termination and let's encrypt. That is a part of the Traefik. We'll play with middlewares that can do some magic with incoming and outgoing requests. And we will see what would be our timing and what I can show you more. So yeah, what are the prerequisites? As I mentioned, as it was mentioned in the notification you received after registering to the page, you need to have a cluster deployed. Kubernetes 1.19 will be enough. However, I'm using 1.20, but it shouldn't be any difference between those two versions. You need to have a Helm installed, because we will deploy Traefik using Helm. Why Helm? Because you are getting a little bit of pre-configured Traefik instance. So you don't have to craft everything manually, like deployment, service, and all those stuff, but you will just get the service instance that is up and running. You can see the dashboard, you can explore how and why it was deployed in that way. using the default values that we prepared in our Helm chart repo. That would be good if you have any external domain that points to your IP address of your Kubernetes cluster, because we'll try to issue certificates from Let's Encrypt. If you don't have it, you can still use nib.io. That is for free. And yeah. Okay, so I think that's all. Let me start with the presentation. So what is the Traefik? And so the Traefik, it's a cloud native router. So it works on the top of your infrastructure, typically on the top of your infrastructure, and can get the incoming request. Typically, it's a HTTP request, but it might be TCP, UDP, gRPC, or something that's because we have also supports for other protocols. But if you send an HTTP request, Traefik is able to understand the HTTP host headers and can do something with that request. So it can route that incoming request to the backend, to the providers of your infrastructure. And as you can see in the slide, there are lots of providers available: Kubernetes, Docker Swarm, or even standard standalone installation on bare metal servers without any orchestrators. But in that presentation, we'll focus on the Kubernetes. So once Traefik will catch that request, it can create dynamic routing. So that request can be transferred to your API server, to your web server, to anything else that is running in an infrastructure. So yeah, what I would like to remember you to remember from that slide is that it's not a web server. It just acts like a router and was strictly written to be a router, not to the web server. So that's very important to understand. And what is the configuration overview? So if you ever seen our documentation, you can notice that there is a static and dynamic. So there are two parts of configuration. So static is entry point. So what is entry point is something that is, you can imagine that is the port the Traefik is listening to. So Traefik can accept the incoming request on that port. So this is the entry point. You can open many entry points, but typically we have a port 80 that refers to HTTP and 443 that refers to the HTTPS. So what is on the left side, it's static. So once you change those configuration, you need to restart the traffic, you need to recycle the traffic. So comparing to those on the right side, those things are dynamic. So all routers you create, all services you are going to create, middlewares, certificates, everything that's related to TLS termination is dynamic. So that's a great solution because you don't have to recycle the traffic, and everything will be done automatically. Yeah, so now we have a slide that is I decided to put that slide here because I would like to explain where actually Traefik is placed in the Kubernetes ecosystem, because the Traefik is a part of the Ingress controller. So if you have a Kubernetes cluster, we have something that is on the top, and it's not a part of the Kubernetes cluster. It's something like an Ingress managed load balancer. So it might be a ELB if you run AWS. It might be Metal LB if you run on premises. But it's something that gives you external IP to connect to your Kubernetes cluster. Then we have a service load balancer. So it's a Kubernetes object, and it connects to the Ingress controller. That in that example is a Traefik, and that service, it just takes the ports. So you have a port 80 and port 433 connected with Traefik. And if the Traefik is running, we have a service that again is connected to your application. So in the discovery phase, when we deploy Traefik and deploy our application in a pod, we need to create service to connect Ingress controller and the pod. So in that case, it will create endpoints in Kubernetes, and then once it's deployed, the communication looks like in the slide. So Traefik is connecting directly to the service It doesn't touch any that is related to the Kubernetes service object. Yeah, I think, yeah, so this is actually load balancing because Traefik can send requests to many services that represent the many instances of one service, so to many pods, and this can be done because it's a load balancer, and it can be a few algorithms to manage how the traffic is distributed, network traffic is distributed. Yeah, and let's compare what we have in Kubernetes. So in Kubernetes, we have three options to expose services. So we have a cluster IP. So that's if you would like to expose any service within a cluster, you can use a cluster IP. You can use also node port, load balancer, but all those three are running in the layer 4. So one invented Ingress that run in the layer 7. So it's a part of the Kubernetes that is called Ingress, and Ingress gives you a lot of nice features. For example, you can use a TLS termination, you can use name-based virtual hosts, you can do something with your incoming request with the headers, lots of nice features. This is actually where Traefik is placed. So I think it's yeah. And what are the providers? Because if you deploy Traefik, you have on Kubernetes, you have a free available providers to integrate with Kubernetes. So first, it's a Kubernetes Ingress. So it's a standard implementation on Kubernetes Ingress that use annotations. You can use the annotations to talk with the Traefik, and Kubernetes will understand that that request should be processed by Traefik. Kubernetes IngressRoute, its custom resource definition is a little more. It provides custom resources that we created on the top of the Kubernetes cluster. And actually, those that I highlighted will be covered in my workshops. Another third option is a Kubernetes Gateway API that is the newest version of implementation of Ingress, but in that session we are not going to cover. Yeah, so hands-on workshops. I think it's all about the first session is finished. I can now switch to my console. I think you can clone the repository because I will be using my repository that is highlighted here. So I will give you 15 seconds to clone it. I will stop share. I will go from the full screen to, yeah. So if you clone the repo, you will get the 15 exercises. So we'll start with the basics, and we're going a little deeper, and we'll try to explore Traefik a little more further. And of course, the Kubernetes. Okay, so yeah, I'm connected to my test cluster. There is nothing installed here. It's just empty cluster. Just pods that are required to keep the cluster up and running. Get nodes -white. So there are 3 nodes, 3 worker nodes, 1 control plane. It's a spin up on AWS, and the version is 1.20.6, but it's not actually important. Okay, so let me go to the exercise number, the first exercise. So let me switch here. In that exercise, we'll install Traefik using Helm chart. So let me go actually here. You have all instruction that I'm going to execute here, so you can follow step by step. And yeah, let's start. So the first step, we need to add our official Helm repository. So you can copy that comment and repo add Traefik. So my repo is already added, Helm repo update. So it will update all repositories that I added to my Helm. And now we will install default installation of Traefik. So I will type that comment. It will take a few seconds, and Traefik should be deployed on my cluster in the default namespace. Okay, since it's deployed, you can ask what default values have been used to deploy Traefik. So you can use you can go to our Helm repo. So it's a Traefik Helm chart, and you can go to Traefik, to values, and you can explore what are the default values that are needed to deploy Traefik. Lots
Jakub,
of
is it possible to make this font a little bit bigger?
Sure.
Thank you.
Welcome. Okay. So all those, there are default values. All of them can be modified locally on your computer and deploy Traefik with your customized configuration. I will do it later on. But currently, we just deploy Traefik using one simple command. Let me explore what has been deployed. So kubectl get nodes. I use a shortcut KGP that refers to kubectl get pods. So yeah, one pod has been created. Let me describe that pod to see what are the default values that has been added to the pod. So some custom labels. We see what is the version, so 2.4.8. We see what's the port, what ports are exposed. So it refers to the entry points that I mentioned earlier, and what are the arguments. So that are the default arguments that are used in our Helm chart. So this is how it has been configured. So we have entry points, 3 ports, one for HTTP, second for HTTPS, and this is internal to use, let's say, dashboard. Actually, to use dashboard. We enable API, we enable health check, and there are 2 providers. So Kubernetes Ingress and Kubernetes CRD. So those 2 providers are available by default. Liveness and readiness checks, because we like to make sure that application is healthy. Yeah, so standard configuration, and it is deployed as a deployment. So the one instance on my cluster. There is also service created. So that service that service load balancer type. So we just explored that pod here, and now I will show you the service load balancer. So kubectl, again, K, get services, as we see, that's the shortcut. So you can see that Traefik created service type called load balancer with that external IP address. So this is the IP address that I can connect to my cluster from the internet. So all users who will be sending HTTP requests will be reaching that IP. So in order to do any extra work, I need to update my DNS entries for the test domain. So I have a simple script here, DNS update, and it should update the test domain. So the test domain is jdemo-trafiklabs.tech. And everything what I put here will be pointing to my external IP. So let me just test d plus short IPP jdemo-trafiklabs.tech. Yeah, so it refers to, it points to my IP address, so I'm able to reach my cluster. Yeah, so we deployed the Traefik. I showed you the pod, I showed the default values, I showed the service that is very important. And now we can, without any extra configuration, we can switch to dashboard. So let me actually change the exercise here. And the easiest command is just to use port forwarding. So let me copy that comment. And it will create port forwarding between my workstation and the pod, because that's with the selector to connect directly to the pod. So now if I will go to localhost, I should see dashboard. So this is the default dashboard that has been installed by default. So let me make it a little bigger, and let's just briefly start to explore, because in each lesson, in each exercise, we will be referring to our to the dashboard to see what has been checked. So 3 entry points, routers, services, and middlewares. Let me show what has been by default deployed. So we have a prefix, path prefix to router created to see actually that dashboard, and the ping command that is a health check. It's related to liveness and readiness health checks in Kubernetes, making sure that the traffic is working correctly. Services, so some Traefik provides a few internal services, for example, API, Prometheus, and ping. So those are internal services that you can redirect you can route the traffic to the service. Middlewares, there is nothing yet created, we'll create later on. We have also TCP routers, TCP services, and UDP. However, in this session, we just only cover HTTP. So yeah, and Kubernetes Ingress.
Quick question, is the script DNS update in the repo?
No, it's actually it's dedicated to my environment, because we use our domain trafiklabs.tech, and it connects to the Cloudflare where the domain is hosted. So if you have any domain, example.com, you probably have any domain provider. So you need to go to that website where you bought the domain, and you need to update DNS entries for your domain to the cluster IP, to the external IP address of your cluster. So it's just strictly related to my setup. Okay, so yeah, let's move forward, because we will be using dashboard much more a little later. Actually, let's run it here. Okay. I'll open new window, and I will back to my computer. Okay, so let's go to the third lesson. So we will deploy the sample app, and it will be again, who am I? A very simple application. So let me go to the exercise 3. And there are 2 objects, Kubernetes objects created. So first, it's a who am I deployment. So it's just a regular deployment that deploys standard application, very simple application that sent you in the response, send you back in the response some headers. So, and it works on the port 80. And in order to, so we are going back to my diagram. So we are just here. So we'll deploy the app. So let me deploy it. kubectl apply -f who am I deployment. So it is deployed. Let me check. Container is just running, just creating. Okay, it's up and running. So now, because it's just a container, we need to expose the port. So in order to do that, we need to create service. So we are using that, we are creating that component. So how it looks like, it's a QMI service. So it's just service that use selector to Kubernetes selector to connect pod with a port. So let me just deploy it. kubectl apply -f QMI service. So it's created, as we see. Yes, it is created. And let me validate it, because we need to validate whether our deployment has been done correctly. So, as I mentioned, Traefik will use endpoints to route the traffic, network traffic to the pod. So if I will use endpoints, kubectl get endpoints, I should see that my application is already available using the cluster IP. Because as you can see here, I created cluster IP type of the service. So now if I will run any sample application, any temporary pod, I can connect to that application, but that network connection is only available within my cluster. I cannot expose that service outside to my user because I have to create Ingress. So, but let me show run-it alpine. So I'm running simple temporary pod on my cluster. It's alpine, so let me install curl update. Okay, it's installed. So now using the service name is whoami-svc. I should be able to reach that application. Whoami-svc. And yes, I got the response. So it was direct connection within my cluster. So since that application has been deployed correctly, and now we can log out from the temporary pod, and now we can create Ingress. So the first, and use the traffic to expose whoami application. So it's exercise number 4. Yeah, so let's go here just to be, yes. Exercise 4. And let me explore it. So let me open the file. And as I mentioned, we are using Kubernetes Ingress. So the kind of that object is an Ingress. The name is whoami-http, and we use traffic. We use an annotation to tell Kubernetes, hey, it will be used by traffic ingress Kubernetes.io. So, and use the entry points web, because now we're just exposing the application using HTTP. There is nothing related to HTTPS yet. So that's the crucial part that you should remember, that if you are going to use Kubernetes Ingress, standard Ingress implementation, all configuration changes related to traffic you are adding to annotations. You can find the list of all available annotation here, because there are lots of them. I mean, that example we use just only the one annotation. Now let me fix that to create the host, because traffic will catch the request using HTTP host header and will route incoming request from the internet to the whoami service. So this is actually what traffic is responsible for. So let me apply Ingress-web. Yes, it has been created. Let's go to dashboard. And yeah, as you can see, the application has been added. Now we should be able to test that application and just to send the HTTP request. So HTTP whoami j demo traffic logs. Yes, and I got the request. So as you can see, I haven't done any configuration in traffic, but I was able to explore dashboard, and I was able to expose one of the test applications. So by default, everything works in that way, because that request has been sent from my computer to my Kubernetes cluster. Let's go back to that slide. So I send the request to the load balancer that is provided by my cloud provider. Then the request has been routed to the service type load balancer on Kubernetes, then to Ingress, and directly to pod. Service has been also created, and we see that there is a one instance up and running. So we have a one pod. So let me check it. That's correct. 1/1 can get deployments. So it's up and running. If you would like to display all created ingresses, we can just execute ingresses-a. So in the default namespace, we created one ingress QMI-HTTP, and that's the URL that is used to access the application. So this, yeah, okay, that's the shorter version. And yeah, let's go to the another session, another lesson. So it's 5. And now we would like to expose the application. We'd like to change everything what is modify, actually, customize our deployment by adding some extra values to our traffic. So again, I was referring to that file. So it's a default values for traffic. You can also execute it Helm show values traffic. So the repository name on your computer, and you should get the same file. So you can explore it and to see what can be changed here. So we are changed here log level to debug. So it will be a lot of logs. Maybe we'll change it later on. We are adding 2 certificate resolvers. So now we are adding, actually, what we'd like to do, we are adding the Let's Encrypt integration. And I'm adding 2 providers, 2 certificate resolvers, staging and production, because if something is wrong with our configuration, we might be very easily be blocked by Let's Encrypt, because the rate limitation is very low in the production. So if you send a bad request and the challenge is not successful between Let's Encrypt and your cluster, you might be blocked. So it can happen here because I don't know how it should work. So maybe we'll then switch to the staging environment. But for now, I would like to show you that Traefik.io, that there are a possibility to create a few actually certificate resolvers. So we use a TLS challenge because we need to prove that we are owner of the domain. We are going to use certificates, and Let's Encrypt use 3 type of challenges. So HTTP, so it will send the request to the HTTP port asking you to provide a specific file, or to the TLS, so it will go direct in the TLS handshake, so it will go just only to the port HTTPS to the 443. So that's why we use a TLS challenge, because it was my decision. You can use a different. And the third one is a DNS. So if you would like to use any wildcard, you need to integrate with your DNS provider and to see what can be, how it should be configured. So yeah, because Traefik keeps the certificates in a file, we need to have any storage enabled. And that's why we have a persistent enabled true. And once I redeploy Traefik with that customized configuration, I should have PVC created on my physical volume on my cluster that use default storage class. So since everything is correct here, let me go to another lesson and let's redeploy. So number 6. So we will just deploy Traefik using the customized volume. So you can use the file created from the exercise 5. So CP values and 6. Let's go to 6. Tab values. Let me double check if there is no any mistake. Traefik. Yeah, seems it's fine. So Helm, upgrade, Traefik. The name of our release that is added locally, the repository, and the custom values that we just created. Okay, we see that the command has been successfully completed. There is a second revision. let me check what has been deployed. So we use Helm LS to see what is the release name, where it has been deployed. So it's a default namespace, revision, status deployed, version of the chart, and the application version. So it's a Traefik version. So now let me just briefly explore it again. So kubectl describe pod Traefik, and we should see the additional arguments that I added to my values. So as you can see, log level has been changed to debug. Format access logs has been changed to JSON format that is more readable for Kubernetes if you have any central logging system, and all those certificate resolvers. So since it's successful, now let me check whether PVC has been created. Yes, so that has been created one PVC, the name is Traefik, it's already bounded, so it's mounted to my instance. So we can see what is inside. So we can exec to the container. So we are inside in the container, so cd data, because this is the path that I indicated in the storage. And all certificates should be created in that file acme.json. Currently it's empty because in the next step we will try to use HTTPS. So let's go to another lesson. Actually it's 7, sorry. Yeah, so now we create Kubernetes Ingress, but for HTTPS. In the previous lesson, one of the previous lessons, we created HTTP, but now we are using HTTPS. So let's go here actually to just, yeah. Okay, so exercise 7. There is one file already prepared. And what has been changed here? So first of all, we use another 2 annotations. So first of all, we indicated that we would like to have a TLS termination running on that endpoint, on that router, and we asking to have a certificates from Let's Encrypt production environment. Hopefully everything should work correctly, and we will get the valid certificates. If no, maybe there's any issue, we'll switch to staging environment. So what I need to change here, I need to update my domain. Who am I? I will just double check whether my services has been not updated. Yes, so it's fine. So now I should be able to deploy that, and as you can see, it will be available on the web secure on the port 443. Let me deploy it. It's deployed. Let's go to the dashboard to see what has been changed. Actually, we deployed. We upgraded Traefik, so I had to create port forwarding once again. So as you can see, we deployed another router. Another router has been created, but it's running on the web secure and use the same domain as HTTP. But currently, we should be able to get certificate correctly. Who am I? J. Yes, we got the certificate, so everything went smoothly. Let me check the headers. Yeah, so we issued certificate just a few minutes ago. The common name is who am I? J demo Traefik labs.tech. There are no any subject, any alternative names created. Just the certificate has been verified correctly. Protocol HTTP2. And we got the correct response. So it seems we are good. we can check another ingresses. As you can see, I created who am I HTTP in the previous lesson. Now we have an HTTPS available here. We can describe PNG. It's time to speed. Who am I HTTPS. So as you can see, that's the host, that's the path, because we are sending everything to the each request to the service from my-svc, and there are two annotations available. So we are successful with the lesson. Let's go to the lesson. Yeah, one nice thing that I would like to show you, we will use a SSL Labs to test how strong is our server. And because we haven't added any special configuration to TLS, we should be probably get the B grade. But because the security is important, in the next lessons, we'll try to improve the security. But let me just run it. It will be running in the background. Demo Traefik labs.tech. Okay. And we can focus on another lesson. So now we will use one of the middlewares, and middlewares are a piece of the configuration that can be attached to many routers. And middlewares can do lots of interesting things. In our case, we would like to have a permanent redirection from HTTP to HTTPS, because currently we have two websites available on two different protocols. So HTTP and HTTPS. But we would love to have a permanent redirection with a code 301 from HTTP to HTTPS. So in order to do that, we need to create middleware. You can learn more in the documentation how it's router, how middleware is created. But it's actually, I will show it here, everything. So yeah. And in that case, we use CRD, because middlewares are the part of the custom of the CRD that Traefik deployed during Helm installation on our cluster. And the name of that object is a middleware. API version, it's excuse me. It's that API version. Specific spec, it's RedirectScheme to HTTPS, and we would like to have a permanent equals true. So let me just deploy it. RedirectScheme. It's added. We can go to the dashboard and to see, yes, the middleware has been created. Please note what are the convention names here, because if you remember here, we use the name RedirectScheme, but here then it's a different name. So what is the convention name? So the prefix is just a namespace name. So we run everything with default. Of course, in the production, you split your configuration across multiple namespaces, but for demo purposes, definitely you can run everything in the default. So default, the name of the middleware that refers to that name at provider. So we run on CRD. So it's up and running. So everything is fine. And middleware, oops. Yes, -yaml. Yeah, it has been created. Now let's do something with that, because there's a reason to create it. So the lesson number 8, number 9. So now we would like to update our annotation in the router we created and have a redirection from HTTP to HTTPS. What is important here, and what I would like you to remember from that section, from the lesson, that we are assigning middleware on HTTP. because the request goes to the HTTP and then it's directed to HTTPS. So that's why we are assigning that on HTTP. So I'm changing the domain here. And we have a entry point web, and we are assigning the middleware using another of the available annotation. Okay, so let me save it. Apply. Okay, it's applied. Let's go to the dashboard to see if something has been changed on our router. Yes, as you can see in the router we created, there is a assigned middleware, and it's exactly mentioned what this router, what that middleware is responsible for. So it's a redirect scheme, and the scheme is HTTPS, provider Kubernetes CRD, and this is the name I just showed you. So now we can just double check if it's added also here. Yes, so annotation has been updated. And now if you will send the request to HTTP, we should get moved permanently. That's correct. So let's have a look on the, what is the response? So yeah, and the response, because we sent get, we get 301, and we are moved to the HTTPS. So it works as expected. -L, and we get the content. Okay, so let's go further. Okay, so it's very simple example. I would like to show you, first of all, to generate some traffic, to also exercise 10. So I will run very simple application that just generates some request. Oops, I did some typo. Of course, there's a typo. So it's, I would say, HTTP ping, but create histogram. So we can see the requests that are incoming to our traffic. And now let me switch to the my console and let me scale the deployment. So kubectl scale deployment, and let's run 8 replica of the whoami deployment. And let's go to the dashboard to see whether our service has been updated. Yes, so we can see that there are 8 servers, 8 pods added. Yeah, all of them are up and running. And here we can see that there is still getting 200. Now let's try to scale down. Let's remove that to 6. Let's scale down to 6. We received 3 502 errors. That is expected because there are no any health checks. But you can notice that there are no any health checks added on the service level on the whoami application. So Traefik was not aware what is the status and tried to send to the unhealthy backends. And we should have a 6 pods. Yes. Okay. So it was a pretty simple lesson. Let's go to the more advanced topics. I can stop it. Okay, now we are moving to CRD. And CRD, as I mentioned, we'll do the same, but we'll use the custom resources created by Traefik to expose services. So exercise number 10 and number 11. So again, its API version refers to the standard, to the custom resource definition by Traefik. The kind of the object is IngressRoute. The name will be whoami-crd, entry points web, and the name will be CRD. So you can compare how it works with the standard Kubernetes Ingress to the CRD. And I prefer to use CRD, but it all depends on your setup. So we'll just redirect the traffic incoming requests to the same application, but using a different domain name. So let me deploy Ingress CRD web. Let's go to the dashboard. Yes, it has been created. So now if we'll go to HTTP IngressRoute, not IngressRoute, whoami CRD, we should get the response from the whoami service. So this is the same service, but those of them they're accessible through the different domain name, but and using a different techniques. One is Ingress and second is CRD. So we can also review the objects that has been created. -A. So that's the CRD we created. This is for dashboard. This is why we can expose, we can see the dashboard. Okay, so now we are going to the lesson number 12, and it's more difficult. Because we'll try to use HTTPS for the CRD for the new domain, but with some extras. Because as you remember, I ran the test here, and we got the grade B. That is not so good, and we will try to tune our configuration for the same application but on a different endpoint to have an A+. So let me go to the deployment to the object. Yeah, so it's more complex. So the same IngressRoute, different name, different endpoint that refers to the web secure, and two matching rules, because I would like to have that my application will be available on CRD-A-J and CRD-A. So two different domain names, but I would like to show you that you can use the OR operator in the host. And now, as you can see, we are assigning middleware default security. So this is default security. It's much more advanced because we would like to have a more secure server, and we are adding some specific headers. So in that case, we use middleware called headers and assigning some headers related to increased security. I'm not going to discuss all of them. You can review it later on and learn more about it. The same is added here because we are creating TLS options. It's another object created by CRD, and we would like to have that our server will accept only TLS 1.2, not lower, and some cipher suits and some curve elliptic algorithms that again increase our setup. And how we are assigning that, we are just using options in the TLS section. So let me change the domain. Because now let's encrypt should create the main domain will be crd.j, but alternative name will be crda.j. This is what we are expecting. Hopefully it should work correctly. So let me just deploy it. I will double check that it's correct. Yes, so let me deploy it. Secure. Okay. It's red because, yeah, now it's green because some of the real dependencies were not added. So I mean the TLS options and the middleware. Let's go to middleware, and we see that we have a security created middleware that is a type of headers. Let's go to CRD. Yes, and we see that there is a much more configuration added. So we see that there are alternative domains added. There are headers assigned that all of them are listed here. And now we should be able to access our application through HTTPS. Hopefully, we got the certificate CRD demo Traefik labs. Yes, so we were successful. We issued dynamic certificate. We can see what is happening here. Yeah, we know what is the common name, what is the alternative, what is the protocol, and we got the application. We got the response from the application. So now let me open the SSL labs in the background and run against CRD jdemo Traefik labs.tech. CRDA should be also, yes, it's accessible. So now in that lesson, we also would like to create redirection using the created previously middleware RedirectScheme. So to have a HTTP to HTTPS redirection. So I'm updating the object for CRD, and I'm assigning the middleware that we created in one of the first lessons. Okay, so curl HTTP CRDJ. Yes, and I'm expecting to be moved to the HTTPS. That's correct. -L. Yes, so we got the content. Let's display some headers. Yes, 301 from HTTP to HTTPS. Okay, hopefully our tests are finished. Yes, they are finished for one of the IP. And as you can see, because we added some extra security headers, we got the overload rating A+. But you should be very careful because you can block some of the older browsers. All of them are listed here. So in order to be on the safe side, you need to tune the cipher suits and all those configs. Because if you are not changing some of the older apps, browsers will not be able to reach your website. Okay, so now let's go to the lesson 13. Okay. Okay, so we would like to have another middleware created that is basic authentication. So we have to first create Kubernetes secret. So how to do that? We use HTPassWD and admin and the password. So those are login credentials that we're going to use. We create the file out. Let's have a look what is inside. Yes, so this is the login and the encrypted password. Now using that file, we create Kubernetes objects. So create secret generic admin secret -- from file and out. The object has been created. Yes, it's created. So let me check whether it's. So we use a JSON path to get the everything what is inside our secret. And as you can see, Kubernetes crypt the use base64 to encode, actually not the crypt, to encode that file. So it's running. So that coded string contains our authentication credentials. So if I will use base64 encoded, I got it the data. So now we can refer to our, we can create middleware basic authentication and combine it with that secret. So let me open the middleware. So again, it's a CRD because it's a middleware. The name is test out basic authentication and the secret name admin secret. So let me save it. Let me apply it. Yes. Let's go here to see whether it's added. Yes, it has been just added. So I think we are good. And now we can, of course, see whether it has been added. Yes, we have a free, actually, middleware. The security was created in the previous step. Now let's go to another lesson. And we'll try to protect dashboard with a basic authentication. Instead of using the port forwarding, I would like to have a dashboard accessible through specific domain. So let me just do that. Ingress CRD. And again, IngressRoute, name dashboard, entry point web secure, and matching rule. And path prefix, because at the dashboard, I would like to have a dashboard, but on API, I would like to get access to my API. Let me just deploy it. And this is important. At the beginning, I mentioned that we use some of the internal services. So this is one of the internal services. And traffic service is another abstraction layer on the Kubernetes services. We use a TLS termination, service over less Encrypt. Hopefully, you will get the cert. And again, we assign the default test out middleware. Quiet Ingress dashboard. Okay, we are running out of time. Yes, it's up and running. So curl https://j demo traffic labs.tech dashboard. I should get 401 if everything went well. Yes, unauthorized because I can even check my certificate has been also issued, so everything went well. And we need to pass login credentials. So we add new password. So those login credentials that we used. And yes, we have a dashboard, so we can go to the browser, HTTP. Admin. Okay, so we see the same, but we use the external domain. So everyone who is still with me can access my dashboard. And now let me show the API, because we have an API that is available, and I highly recommend to use it. So the version, you can get the version of the traffic, the code name, and some raw data that we need to pass to JQ. And as you can see, those data are related to what we have in our beautiful dashboard. So yeah, let's go to the last lesson. That is, I think, the most difficult, but let me show how we can manage it quickly. Prometheus. So first of all, we need to enable, we need to again change the configuration of traffic by adding that parameter. So values and yeah, fix. Okay, persistent enabled, and I added another line here. Metrics Prometheus equals true. So let me just install it. Can describe pod traffic. Describe traffic. Okay, it's added, so we should get the access to our metrics. So let me just run the test outline image. Again, we don't have a service code, so I will manage it later. So it will enable endpoint metrics, but in order to, we can also see in the dashboard that metrics should be. Okay, maybe I did something wrong with my, or maybe I was blocked. Okay, never mind. Actually, it's not a part of the session. Let me go to here and try to deploy Prometheus. So we need to expose dashboard, actually Traefik Dashboard, and refer to the endpoint metrics. So I'm creating a specific Traefik Dashboard service, as we see, outline. Traefik Dashboard, port 9000 metrics. And as you can see, Traefik exposed all metrics to me. So but now we'd like to visualize them. So it's a bonus lesson that has been not mentioned earlier. Let me just briefly manage that. Hopefully we'll get Prometheus up and running. So again, I will use I need to add the repository I added earlier. I created a custom values referring to the documentation of Kubernetes Prometheus stack. So let me see what I added here. I added some extra plugins, pie chart panel, dashboard provider, and I imported by default one of the example dashboards. So we are not going to do anything, any manual work after deploying. So let me just deploy it, install Prometheus stack, repository Prometheus community, and the file. It will take a second. Okay, it's starting. Initial. Okay, it is deployed, so all pods should be, almost started. Traefik service monitor. We create service monitor. It's strictly related to the configuration of Traefik. The white space here. Yeah, I will deploy it. Traefik service monitor. So it's deployed. And now let's create the port forwarding to see whether our Grafana is able to connect to our dashboard and get the data from Prometheus related to traffic. So I'm creating a port forwarding to the service Prometheus stack Grafana, and on the port localhost 8080, I should get login page to Grafana. Okay, it is loading. There are information how you can get the username and password. So it's admin and prom operator. Admin prom operator prom dash. Okay. And I imported in my code here, in my configuration here. This is a definition of the dashboard that I added. So I should see it's the number of the dashboard from the marketplace of Grafana dashboards, and we should see that yes, we have a dashboard. We have everything available here, and yes. Yeah, so there are no too much traffic, so there is no enough data that should be displayed. Let's check the last 5 minutes. And yeah, so we are able to get the metrics from traffic and display them in Grafana. So I think it was the last lesson. Yeah, you can also have a look on one of our blog posts. That is more information about the integration of Prometheus and traffic. You can use the alerts here and lots of notification. Okay. So thanks a lot. And if you have any questions, I will definitely answer them later on and publish on GitHub repository.